So you're just done with your quiz number 1. Now we're going to continue with our lecture. And this will include, or this will be in your modular exam 1, which will be next meeting. So last lecture meeting, we answered up to number 3 for resultant parallel forces. Now let's move on to number 4. So prepare your calculators so we can solve this quickly. Number 4, the resultant of 3 parallel loads, one is missing in the figure, is 13.6 kilograms, acting up at 3 meters to the right of A. Compute the magnitude and position of the missing load. So we're given the resultant. So this is your figure. That's number 4. Okay. So once again, we're given the resultant for this figure, R, which is 13.6 kilograms acting up. Acting up at 3 meters to the right of A. So this is A actually. Okay, so 3 meters to the right, let's draw that as such. So this is an estimate of 3 meters to the right of A. What are we looking for? Compute the magnitude and position of the missing load. So there's supposed to be 3 forces here that creates a resultant R. So it's easy enough to figure out what that magnitude is just by using your summation of forces. Okay, so resultant, remember, is equal to summation of forces. Resultant is 13.6 kilogram upwards. So 13.6 upwards, therefore positive, then equals summation of your forces present. So let's start with 18. So 18 is upwards, therefore positive. 27 is upwards, therefore positive. Then we don't know the direction nor position of your missing force F. So you can just write F. So let's assume that it's positive, okay? So assuming positive F, solve for F, what's the answer? Negative 31.4, correct, Angela and Jermaine. So the Guzman and Borde. Are you late enrollee, Angela? You're not in my list, I guess.
Garing ko yung surname po.
Okay, sorry. Oh, yeah. Hindi naka-full extend yung name mo sa akin. My bad. Garing. Okay, so once again, it's negative 31.4. Now, what does this negative mean? It means that our assumption for the direction of your force is incorrect. So we assumed it's upward. This is a negative, therefore assumption correct. So it's the opposite of that. So it's 31.4 kilogram downward. Okay? So now we know it's downward. Now you're gonna guess where is the position of that. Because that's one thing we also want to look for, position. So let's guess it's downward. I know, we already know it's downward. So I'm gonna guess it's somewhere here. Okay? It's to the right of A. And I'm gonna put my force there. To get the position of that, you're now gonna use a summation of moment. The summation of moment about A, recall, is just resultant times D. This is for all the individual forces. So let's start with 18. 18 is counterclockwise, so negative. 18 times distance from A, perpendicular distance, it's just 0.6. Next, F, rotate F about A, that is clockwise. So positive F. Wait, let me just mute that. Yeah, again, that is positive F multiplied by distance, which is, let's put it as X. So F times X. And then 27. So rotating it about A, that's counterclockwise. So negative 27, then distance 0.6 plus 3.4, that is just 5. Right? No, 4, sorry. There, and then equals, rotate R about A. So R is counterclockwise, therefore negative 13.6 multiplied by distance 3. Now I can solve for X. What's the answer? Castillo, Kathleen and Angela correct 2.48. So Castillo and Garen. Castillo. And then unit meters. So this is meters. Okay. So there, that's just your number 4. So that ends your resultant of parallel forces. Let's move on to the next topic, which is couple. So sometimes a resultant force system will be 0 in magnitude and yet have a resultant moment sum. This moment is said to consist of a couple. Okay, so a couple, therefore, is made up of two equal, parallel, oppositely directed forces. So just imagine if you have two forces that are equal in magnitude, but opposite in direction, if you get the summation of that, that will be 0. Okay, resultant 0. However, there will be a resultant moment sum, and that is your couple. Okay. So to get your couple, you multiply the force, since they are equal in magnitude, so it's just force, multiplied by the distance between them. So for example, here, you have your force equal in magnitude, opposite in direction, then multiplied by distance d, that is your couple C. And that distance is what we call your moment arm. So moment arm is perpendicular distance between the action lines of the forces. Once again, it's this d. That's your moment arm. So couple is independent of the moment center, thus the effect is unchanged in the following conditions. Couple is rotated through any angle in its plane. The couple is shifted to any other position in its plane, and the couple is shifted to a parallel plane. So this means that even though, for example, you have 4 points in your system and you have a couple there, even though you take, let's say, summation of moment at A, B, C, or D, it doesn't matter. The equivalent of your couple is still the same. Okay, that's why it's independent of what's happening or where your moment center is. Also, no matter where you place your couple in the system, okay, its value is also the same. Yeah. Even though it's rotated, even though it's shifted in position, and even though it's shifted to a parallel plane, the effect of your couple is still the same. So let's have a few examples for that. Let's start with number 1. Determine the resultant moment about point A of the system of forces shown in the figure. Each square is 1 feet or 1 foot. So we're just looking for resultant moment. Okay. So this is something we've done earlier. Okay. So couple is just an addition to your concepts explained in our past topics. So we're looking for summation of moment at A. We already know how to do that, right? It's just summation of forces and their perpendicular distances, or components and their respective distances. Okay. So therefore, summation of moment at A. You can start at any force. Let's start here. So remember, whenever we're taking summation of moments or resultant for that matter, we can either use the perpendicular distance, okay, which is this, or the components. And whenever you're getting components, we place it in such a way that one of its components cancels out. So for this force, 100 pounds, I'm gonna position my components here. Okay, because as you can see, this portion cancels out. So now I need the horizontal component of 100 pounds. So to get that, I need the slope of this. So let's take the slope. Again, to take the slope, if you're given a grid, just count the number of squares. So taking this is one square base or one side base, and this is two sides height. So that's 1 and 2. Then get the hypotenuse, that's square root of 5. And obviously, you're going to do the same for other slanted forces. So let's do that for here. So again, count, this is, okay, considering this right triangle, this is 3 sides base, 2 sides height. So this is 3, this is 2. Getting the hypotenuse of that is just square root of 13. Okay. Okay, going back again, using this, it's the horizontal component of your 100. And to get the horizontal component, just write the force multiplied by the side that is parallel to your force. So it's 1 over hypotenuse square root of 5. And then, don't forget your sign. Rotate it about A. This is counterclockwise, so therefore that should be negative. Okay. Next, let's do this. So there's no actual position where your forces cancel out. Okay, or there's no obvious position where it cancels out. So you can put it anywhere. So let's say I place it here. Okay. So let's start with the horizontal component of this. Rotate it about A. Once again, that's counterclockwise. So negative, copying your force 200. Again, this is horizontal. So side that is horizontal, that's 3 over square root of 5 multiplied by distance. Oh, I forgot to multiply by distance here. Okay. So this is only the horizontal component multiplied by distance. We're taking it about point A, so this is the perpendicular distance, 1, 2, 3, 4. Okay. So moving on again here, this is the horizontal component. Perpendicular distance is 1, 2, 3. So multiplied by 3. Next, the vertical component, rotate it about A. So that's positive. So plus, get the vertical component, 200 times 2 over square root of 13. Then perpendicular distance, it's this. So that's 2. Now we have these forces right here. And if you've noticed, they are, let's start with AP. They are equal in magnitude but opposite in direction. So we have an example of a couple. Okay. So what we do with a couple, if we're taking moment, okay, you're just gonna take the force multiplied by the distance between them, and sign convention applies. So rotate your couple. Okay, so this is upward, this is downward, upward, downward, upward, downward. That is clockwise. So that's positive. So positive, this force is 80. Then distance between them is, yeah, 2 sides or 2 blocks. So times 2. Do the same thing for the other couple, and as you can see, they are equal in magnitude but opposite in direction. So that's another example of a couple. Then rotate it, okay, following the arrows. And if you've noticed, this is counterclockwise, right? Counterclockwise. So minus 100. Now, the problem is I want to get the distance between them. And how do I do that? Well, if you've noticed, this force intersects this point. This force intersects this point. Okay? And that is the distance or the perpendicular line between them. And that is just the hypotenuse of this right triangle. Okay? So this is 1, this is 1. Therefore, this is square root of 2. So therefore, distance between them is square root of 2. Okay? So please compute what's the answer. Oh. Oh wait, sorry. This is positive. Horizontal component, that is clockwise. So that's supposed to be positive.
Nakalugaw.
Wait lang. May mali na naman ba akong sign? Plus 203 square root of 13. Oh. Okay. Yeah. That is square root of 13, not square root of 5. Correct. 560.80. Sino yun? No. 560.80. So, Erwin and Angela. Okay. 2 points ka na. So, next one. Duka. So, Nabayo and Kathleen Duka. Nabayo and Duka. Yep. Duka. Nabayo. Yeah. Okay. So, correct. It's 560.80. So, as you've noticed, even I make small mistakes. So, make sure, yeah, your sign is correct and the hypotenuse that you write is correct. Especially when it comes to a lot of forces, it's tedious to keep track of the values. Okay, so that's number one. So easy enough. That's just looking for summation of moment. Next, let's move on to number two. So the three-step pulley shown in the figure is subjected to the given couples. Compute the value of the resultant couple. Also determine the forces acting at the rim of the middle pulley that are required to balance the system. Okay. So just resultant couple. So that's just your summation of C. Let's start with the innermost rim here. So figure out its direction. So following the rotation that is counterclockwise. So that is negative. Magnitude of the force is 60. Then distance between them, as you can see, that's 8 inches. So times 8. Next, the blue circle. So rotating that is clockwise. So plus 30. Distance between them is 12. And then lastly, 40, rotating that is counterclockwise. So minus 40. Distance between them is 16 inches. What's the answer? Correct. John and Jasmine, Horace and Alanis. Alanis. Horace. There. Yeah. So negative 760 unit. So this is force times distance. So that's just your unit for force times unit for distance. So pound inch. And this negative just means that this is counterclockwise. So or 760 pound inch counterclockwise. Or you can just write the whole term counterclockwise. Okay? And the next part, determine the force acting at the rim of the middle pulley that are required to balance the given system. So to balance the given system, that means that the resultant of your forces is 0, which is our next topic, okay, after resultant. So this is a sneak peek to that. So to get that balance force, we're just gonna equate it to the magnitude. Okay. So C equals FD. That is what we're looking for. C is the resultant. Okay. So now what you're gonna do, we're gonna take the magnitude of your couple, the resultant couple, which is 760, then equate it to your force. And it states here in the problem, force at the middle pulley. Okay. So our resultant is counterclockwise. So to counter that, my force should be clockwise. Okay. So now establishing forces clockwise, the direction would be this as well on the blue pulley or blue circle. So that's your F. And distance between them is still 12, since again, we're restricted to placing it at this circle, so 12. Therefore, solving for F, we get 63.33. So Alanis and Dupre, Jasmine and Kathleen. Okay, so 63.33. And again, since this is counterclockwise, this needs to be clockwise to cancel that out or to balance that out. Okay? So we'll talk more about this next topic. And then number 3, a vertical force P at A and another vertical force F at B in the figure produce a resultant of 100-pound down at B and a counterclockwise couple C of 200-pound foot. Find the magnitude and direction of forces P and F. Once again, we have P at A, F at B. Direction is not given, so we have to guess first. So you can make an intelligent guess, or for example, you didn't, you just randomly selected your direction. That's fine. So let's say I wanted this to be upward. Once again, P at A, F at B. And let's say I guessed that F is downward. Okay. So what we want is finding the magnitude of P and F. And according to the problem, P and F creates a resultant here with a couple there. Okay. So what do we do? So this means that this effect by P and F should equal this effect by C and R. Okay? Therefore, the summation of moment and forces of P and F should equal the summation of the forces of this couple in R. Okay? So let's start with moment. So usually, similar to taking the components of a force, you want to take your moment at a point where one of your unknown forces cancel out. So in this case, it's either at A or at B. So let's take moment at B so that F cancels out, because remember, any force that passes through your point in question doesn't contribute moment to it. So that, again, let's start with B. The summation of moment at B. So let's do that here. Summation of moment at B is equal to summation of your single forces times their perpendicular distances. Okay? So this is for the resultant, this is for the single force. So let's start with here, resultant, R. Again, we're taking moment about B, so rotate R about B, that is counterclockwise. So negative 100 times perpendicular distance is this. So 4 plus 3, that's 7. And don't forget we have a couple here. Remember, the effect of a couple doesn't change whether you put it B at A or at B. Okay, its effect is the same. So you just have to know its magnitude and direction. This is counterclockwise, right? If you rotate that, that is counterclockwise. So that's negative. And then magnitude 200. There. And equals P. My guess was P is upward. So following that direction, that's counterclockwise about B. That's, sorry, clockwise. Yeah, clockwise about B. So positive P times perpendicular distance, 3. Solving for P, what do we get? Yes, 300. So, Balubar, Johnson, and Noel. So, Salvo and Balubar. Remember, 2 recitation points max. You can only answer if no one else is answering. Balubar, Salvo. So, yes, P is 300. And is that a positive or a negative? It's negative, to be precise. Okay. By the way, if you answer, include your sign, because that's important. So I got negative 300. So that means my assumption is incorrect. So therefore, it should be the opposite direction. I theorize it's upward, it's incorrect, so that should be downward. Okay? So that is what that means when you guess wrong. When you're equating two equations. Or when you're using two equations. Okay, now I have my P. To get F would be easy. That's just summation of forces vertical. R equals summation of forces vertical. So my R is 100 downward, so negative 100, again since downward, equals. So when you're going to create another equation, okay, you can either correct this, erase this, and know that this is downward, or you can stick to your assumption, just use the answer that you got. Okay. So again, my assumption this is upward, so I'm going to write positive P, and then negative F. And then negative 100, even though you wrote positive P, you're going to use now the answer that you got, which is negative 300, okay, minus F. And then solve for F, what do we get? We got negative 200, correct. So correct Gian and Johnson. So, pobre, balong. Pobre, balong. So I got negative 200, which again means my assumption is incorrect. Magnitude is correct though. So I assumed it's downward, therefore the answer should be 200 pounds upward. Okay? So that is what you're gonna do if you assumed wrong. Don't worry, magnitude will be correct. You're just gonna have to correct your direction. Okay? So that's numbers 1, 2, 3. Do you have any questions so far? Please answer in the chat or your mic, yes or no. Okay, sure. Okay, good, good. Since you don't have questions, let's move on to the next part. Okay. Number 4. Number 4. A short compression member carries an eccentric load, 200 pounds, situated 2 inches from the axis of the member, as shown in the figure. In strength of materials, it is learned that the internal stresses are determined from the equivalent axial load and couple into which P may be resolved. So determine the equivalent axial load and couple. So for those who will take strength of materials, this is something that you'll do often. This is what you call an eccentric load. Okay, if your load is not acting at the center of your object, or acting at the axis. So this is the axis of your object. So this is an example of an eccentric load. In strength of materials, usually we resolve eccentric loads into axial loads plus a couple. So to do that, okay, we're gonna redraw this. So let's redraw. Just copy. Delete that. And then magnitude would be the same. Let's do that. Let's use green. So the magnitude would be the same. P is still 200. However, you're going to create a couple. And the direction of your couple would be following your eccentric load. So you have P here. So about the center, because you're going to move your couple to the center. So rotate P about the center. So that's clockwise. So therefore, the resulting couple should also be clockwise. So that's your couple. Okay? So now I know force is just, or let's call this resultant force to make it different. So R is your 200 pounds. And then couple is just force times distance. The force is 200 times distance 2 inches. So that is just 400. Okay, I don't need you to solve for it. So 400 pounds. And then inch, because we are using inches. So, ganyan lang. Force times distance for couple. That's it. And then lastly, number 5. Replace the system of forces acting on the frame in the figure by a resultant R at A and a couple acting horizontally through B and C. So like what we did at number 4, where you have a single force and you transformed it into a resultant plus couple, we're going to do the same thing for 5. We're going to take the resultant of all of this and then place it at A plus a couple at B and C. Okay? So the problem is, I don't know the direction of A. I don't know the direction of B and C, but I can intelligently guess that the direction of A would be, just looking at this, I got 20 and 60 downward, 30 upward. I can guess that A or resultant should be downward as well, since that is the majority of my forces. Okay, so intelligent guess, this is your R, downward. And to solve for that is easy, it's just summation of forces. So R is just summation of forces. Okay. So let's start at the left. So 20 is downward, so negative 20. 30 is upward, so plus 30. 60 is downward, so minus 60. What do we get? 50, yeah. Negative 50. So correct, Jasmine, but you already have 2 points. Rosaline, correct, and then Carla. So Ellie and Ibarra. B, C, D, E. Ibarra. I. Okay. So that's negative 50. So this just means, again, force is downward. R is 50 kilonewtons downward. Now you might get confused. I assume this is downward. Why did I get a negative? Remember, I'm not equating anything. I'm just getting the value of R. So whatever the sign of that is the direction of my unknown value. Unlike earlier, I was equating something to another equation. So if I get a negative, that means I did it incorrectly. Okay? Remember that. Remember what happens when you get a negative sign. Okay, so that's my R. Now next problem is I want to add a couple here at B and C. So remember, all of this should equal the effect of R plus a couple. So therefore, the moment of your individual forces should equal your couple as well. Okay, or should equal the moment of your R and your couple. So now create an equation out of that. So to make things easy, once again, you're gonna take moment about a point that would cancel out your unknowns. I'm gonna put it here at A, since that cancels out your resultant and this 30 kilonewton force. Okay. Remember, your couple doesn't matter where you take your moment; its effect should still be the same. So summation of moment at A is equal to forces times distance. So let's take moment at A. So R cancels out. So C, now I have to guess, take an intelligent guess of the direction of your C. Should it be clockwise or counterclockwise? So I'm gonna guess it's clockwise. So that would be this way. So that's your F. So therefore, moment at A due to couple F is just F times D. And D is 2 meters. And then positive, since again, I assumed it's clockwise. Then equals F times D. Let's start with 20. Rotate 20 about A. So that's counterclockwise. So that's negative 20. Multiplied by distance from A, that's 1. Next, R and 30 pass through A, so skip that. And then next, 60. Rotate it about A, that's clockwise, so positive 60. Times distance. Perpendicular distance is this, which is equal to 4. Okay? And then compute What's our value for F? Yes, correct. It's 110. So we got it first. Vivian and Julia. Correct. It's no. It's not 100. Sorry, Vivian. So Julia and Erwin, Solomon and Nabayo. Lemon, Solomon. Okay. So 110. Answer is positive. Therefore, my assumption is correct. Okay. And therefore, my couple is equal to 110 times 2. So 220 kilonewton. Our unit for distance is meter. And then clockwise. Okay. So what are we asking again? Replace the system. So we're going to replace this system now. So we're going to remove. So now replacing the system. Yan. So this entire system is equivalent to this. So R plus couple F, where R is 50 kilonewton downward, F is 110, and your couple is 220 kilonewton meter clockwise. Okay, that's your number 5. Oh, sorry, Vivian. Next time. Don't give up. You all will get your chance. Okay. So that's your 4 and 5. Any questions for number 4 and 5? None? Please answer in the chat. Any questions? All right. Thank you. Yeah. Good. Since you don't have questions, let's move on to the next topic, which is the last topic for resultant, which is resultant of non-concurrent force system. And this is just a combination of all your topics so far. So the effect of an unbalanced non-concurrent force system on a body is to give the body a motion consisting of a combined translation and rotation. So translation effect is determined by resultant R. Rotational effect is determined by the moment of the resultant force. So now we're going to do a combination of resultant and moment here, much like what we did with parallel forces. But now we're going to deal with two directions, X and Y, or whatever your axis is. Okay, so therefore, all of these equations now are applicable for resultant of non-concurrent force system. Okay, once again, it's a combination of everything, of every concept we've learned so far. So let's have a few examples. Okay, let's start with one. Determine completely the resultant of the forces acting on the step pulley shown in the figure. So when we say determine completely, that is getting the magnitude of your resultant, its inclination. Inclination is angle from the x-axis. Okay, its position. So 3 things. So let's start with magnitude since that's the easiest. Okay, this is number 1. So to get the magnitude, we're gonna do something that will do a lot for MEC 30, which is summation of forces x and then summation of forces y. Let's start with x. We're gonna take the summation of forces x first, because to get the resultant, it's just square root of rx squared plus ry squared. So rx is summation of forces x. And let's start with the topmost. So to get the x and y components, we usually need angle or slope. Here, what's given is an angle. Okay. So if I draw this, if you remember what I said in our previous meetings, or if you remember from your trigo or solid jump, so in alternating interior angles have the same angle. So this is 60, therefore this is 60 as well. Okay, 60 degrees. I remember our equations where x component is force cosine theta and force y is equal to f sine theta. Theta should be taken from the x-axis. So I want to get this. Okay. Yeah, this angle. And this 750 force is acting tangentially to your circle. Okay. Denoted by this line, perpendicular line to your force. So therefore, this line is perpendicular to this line. So this total angle is 90. Therefore, 90 minus 60, this is your 30. Okay? Well, let's choose a different color. Blue. And 30. Once again, why? Alternating interior angles. So this is 60, 60. These are right angles because this is tangential to your circle. So therefore, 90 minus 60, get 30. So to get the x component now, this is to the right. Sign convention still applies. This is to the right, so therefore positive. 750 cosine angle 30. Next, this doesn't have a horizontal component, and this is to the right, so plus 250. What's the answer? Paano magdadagdag sa grade? Yung recitation. So final grade. To that, yeah. So to explain, I'm gonna take the summation of your grade, take a percentage of that, and add it to your final modular grade for that session or for that time period. So summation for module 1 of your recitation points, get a percentage of that added to your final modular grade. So that is what recitation points are. Okay. So again, what is RX? 899.52. Correct, Angela? Correct, Jan? Correct, Rosalane. So Torres and Ali. Torres. Ali. Ali. No. Okay. It's 899.52. Store this. For those who solve, store that to make things easier. Store it in your calculator. And now do the same thing for y. This is upward, therefore positive, 750 sine 30. This is downward, therefore negative 1250. This doesn't have a vertical component. So what is ry? Correct. Negative 875. So correct. Now. Andre and Jermaine. De la Vega Borbe. Oops. Okay. Negative 875. Okay. So now, getting r, that's just square root of rx squared plus ry squared. So please solve using the stored value. Once again, store that. You don't need to store that. Yeah, just solve for it. square root of rx squared plus ry squared using the stored value of rx. Hmm? Why are you getting that answer? Squared, ah? Squared. Yon. Correct, John. Correct, Jermaine. Correct, Kath, Castillo, Jasmine, Jade, Angelo. But you know who are you kanina? It's 1254.89. So let's give it to the first ones who got it right. So it was Torres and Borbe. So, yun. So again, 1254.89. So did you get the other answer? So that's the magnitude. Next, inclination. Oh no, this is squared. We're just getting the value. We're not equating anything. So getting the value of ry, this is negative 875. That just means your ry is downward. Okay. And then r is rx squared plus ry squared. Okay. Signs only change if you equate two equations. This is just getting the value. Yeah. Next, inclination. That's just using your equation theta equals arctangent ry over rx. Now here, you're gonna get the absolute value. Okay. So what's the answer? Yeah, 44.21, correct. How about those who participated every day pero di lang nauuna sa pag-chat? So there's gonna be a time when we're almost done with the term. And then I'm gonna ask everyone who doesn't have a recitation point yet to recite, so that everyone has a chance to recite. Okay. So one of these days, I'm gonna call on those who don't have recitation points yet, instead of asking volunteers. Okay. Oh, 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 John, ikaw na yung nauna. John, Carlo, Relor, correct, and then De La Vega, correct. 44.21. Relor, De La Vega. Nice. Relor, De La Vega. 100. So yeah, it's 44.21 degrees. And then to complete the answer, write the direction. The direction comes from the sign of your answers. Rx is positive, therefore to the right. Ry is negative, therefore downward. So downward to the right. Okay, so that's your inclination. And lastly, position. So to get position, we're gonna use moment. Okay, so you're gonna take a reference point. You can take it anywhere, wherever is convenient. So let's say I take it about the center. So summation of moment about the center is equal to your resultant times perpendicular distance from it. Okay, so let's use that equation. So let's start 750 rotated about O. Okay. So that is clockwise. So positive 750 times, there's already a perpendicular distance. And it's 1 1/4 feet. And that is equal to 1.25 feet, right? 1 1/4 is equal to 1.25. Next, 1250. Rotated, that is counterclockwise. So negative 1250 multiplied by half an inch, which is also equal to 0.5 inches. And then lastly, 250, rotated about that is counterclockwise, so negative 250. Again, distance from center to outer circle is 1 1/4, so that's 1.25. Equals RD. What's D? 0, yeah, correct. 0. So what does that mean? So Kath, correct. Noel, correct. Jasmine, correct. Julia, correct. So yung wala pang 2 points, that is Castillo and Salvo. Correct, 0. So therefore, where is your resultant? Are at the center, or center of axis. Okay. So that's number 1. Any questions for number 1? Okay. Ay, wala pang points. Wait lang. Magkaka-points din kayo. Mauubos din yung mga ano. Mabibilis yung internet connection. Oo. Marami pa naman. 15 questions to. So that's number 1. Since no questions, we can move on to number 2. Okay, completely determine the resultant with respect to point O of the force system shown in the figure. Once again, when we say completely, that is looking for the resultant, the inclination, and the position. So let's take the resultant first. So again, let's start with Rx. So Rx, let's start with the leftmost force, 240. Now look here, my angle is given from the y-axis 30. So I can use that. Or if you want, if you're used to taking the angle from the x-axis, you can just solve this. This is equal to 60, right? Since this is 90. If you don't want to do that, that's fine. You just have to understand, taking the x component means taking this component. And this component, yeah, taking that component. And this is equivalent to this, which is the opposite to 30. So my equation now would be 240 sine 30 for the x component. Okay? So you're not really restricted to taking the angle from the x-axis. You just have to understand, if you're taking it from the y-axis, the x component would be 4 sine theta. Okay? Because again, this is your x component, which is equivalent to this line as well, and that is opposite your angle. So sine is opposite. Okay? Yeah. And it's it's to the left, therefore negative. Yeah. Next, let's start on 141.4. I'm given a matrix, so I'm gonna use slope to figure out the slope once again. This is 1 block, therefore this is just square root of 2. So this is to the right, therefore positive 141.4 times horizontal component, so it's this, times 1 over hypotenuse square root of 2. And the next, here, it's to the right, so plus 300. Once again, the angle that I'm given is along the y-axis. But remember, x component is this, right? So that's opposite, so I'm going to use sine. Sine 60. And lastly, this one is to the right as well, so plus 260. Now I need to solve for the hypotenuse of this. which is just square root of 12 squared plus 5 squared, and that is 13. So plus 260 times horizontal component, so that's 12 over hypotenuse 13. What's the answer? Yeah, it's not cosine because again, you're using cosine if the angle is from the x-axis. Okay? The angle given is from the y-axis. That's why we're using sine. So sine is opposite, and that is the exact component we need. Okay? So correct, it's 479.79. Got it first. Mark and Gian. So kaya biyag and over. Okay. So store that. 479.79. Store. Do the same for RY. Again, let's start here. This is upward, therefore positive 240. I want to take the vertical component, which is this. And that is adjacent to your angle, and therefore I'm going to use cosine, since cosine is adjacent over hypotenuse. Okay, so cosine 30. Okay, once again, to reiterate, x is equal to f cosine theta if theta is from the x-axis. Here, this theta is not from the x-axis, so I'm not going to use that. Or again, if you're used to that, you can just solve this to be 60, therefore 240 cosine 60, 240 sine 60 for this. Okay? So you can practice doing that at home. Okay, next, this is upward, therefore positive. So 141.4 multiplied by vertical component 1 over square root of 2. Next, this is downward, therefore negative 300. Vertical component is this. Again, it's adjacent to your given angle, so I'm going to use cosine 60. And then lastly, this is upward, therefore positive 260 times vertical component 5 over 13. What's the answer? Correct, it's 257.83. Got it first. John and Skylar. So, Relor, pamat-mat. Kumota ka na, John. So, once again, 257.83. And again, store that. So that when you solve for rx squared plus ry squared, what's the answer? Yes, it's 544.68. Correct, Vivian. And Navarro. So Vivian and Navarro. Bajo and Navarro. And so Vivian, may point ka na. Okay. So once again, that is 544.68. Newton. So that's magnitude. Next, inclination, which is theta. So arctangent, ry over rx. What's the answer? It's correct. It's 28.25. So who got that first? So correct, John, Kathleen, Jade, and then Sophia. So Simon De Leon. Simon De Leon. Simon. Okay. 28. Yes, 2 points quota every day for now. Okay? Para maraming makakakuha ng points. So if you've noticed, I'm not giving you points even though you got it first. It's because naka 2 points ka na. So I'm giving it to the next ones. But you can still answer. And you can still gain points if no one else answers. So 28.25 degrees, to complete this answer, write the direction. Rx is positive, therefore to the right. Ry is positive, therefore upward. So direction is upward to the right. And then lastly, position. Okay, so we know this is upward to the right. Okay, so now we're gonna use moment, just like what we did earlier, to get the position. So instead of equating two equations to immediately get the position, let's try solving for the moment first. Okay, summation of moment about O. Okay. So 240 passes through O, so I'm gonna ignore that. Next, 141, I'm gonna place the components here so that this part cancels out. So I'm only interested in the horizontal component. So horizontal component rotate about O, that's clockwise, therefore positive. Horizontal component is 141.4 times 1 over square root of 2 multiplied by perpendicular distance. This is 1, 2, 3. Next, the 300 Newton force. Again, you can either get the perpendicular distance or use its components. Let's do that. So none of them cancels out. So let's start with the horizontal component. Rotate it about O, that's clockwise, therefore positive. 300 sine 60. Again, this is the horizontal component multiplied by perpendicular distance. So extending its line of action, this is 1, 2, 3, 4 sides or 4 boxes from O times 4. Next, the vertical component, rotate it about O. Again, that's clockwise. So positive 300, vertical component is 300 cosine 60. Then vertical, perpendicular distance, extending that, this is 1, 2, 3, 4 boxes. Once again, times 4. And then next, the last one, this 260. So I'm gonna place I don't think I have a choice. Yeah, put it there. So once again, let's start with the horizontal. Rotating it about O, that's positive. 260 horizontal component, 12 over 13 multiplied by perpendicular distance. And that is just 1. And then last, rotating it, a vertical component, rotating about O, that's counterclockwise. So minus 260 times vertical component, 5 over 13 multiplied by distance. That's 1, 2, 3, 4. 4. Okay, please solve. What's the answer? 1779.19. Is it positive or negative? Negative. Yeah, positive, negative, positive, negative. Negative na kukuha niyo? Diba? Eh? Positive. It's positive. Bakit kayo may negative? So correct, Carla and Angela, yes. And then Sophia, yes. So Carla, so Batun, and the Leon. Ayan. Carla, may score ka na din. Yes, correct, positive. Hindi ko alam ba't kayo nagkaroon ng negative. Julia. Yeah. Teka lang, let's check. O nga, no? Yeah, sorry, Julia is correct. And DeAndre, Ibayo. My bad. So, Solomon and Ibayo. Solomon, Ibayo. Ay. Yan. Okay. So, positive, therefore, this is clockwise. Okay. Kilonewton meter clockwise. So, therefore, my resultant should also create a clockwise moment about O. So, redrawing this. Okay. Again, this is O. I know that my resultant is upwards to the right. So I have to draw it in a way about O that creates a clockwise moment. Okay? If I draw it here, and again, this is O, and the moment would be this way, which is counterclockwise. So that would be incorrect. Therefore, the correct way to draw it would be here. Yan. Because rotating it about O creates a clockwise moment. So now this is my positioning of R. So to get the values, if you've noticed, this is now what we call your IY and your IX. And we've already solved for IY and IX before. So we'll just do that again here. Remember, let's start with IY. To get IY, I'm going to position my components for R here. Okay, so this is RX, RY, same thing here. Again, RX, RY. RY passes through O, so I'm left with RX. So summation of moment at O equals RX, and then perpendicular distance is IY. I know MO, it's this. I know RX, it's this. So I can directly solve for IY. Please solve for IY. What's the answer? Forgot to say store. Why are you getting that answer? Um, I know. Nag-multiply kayo. Okay, I'm gonna give it to Mark and Jasmine. So kaya Biab and Alanis. It's 3.71. 3. So I think you're multiplying. So MO, 1779 divided by RX, 479. So divide to get IY, okay? IY is MO over RX from this equation. So it's 3.71, then unit meters. So that's your IY. Next, do the same thing for IX. So once again, summation of moment O. Looking here, Rx passes through O, so I'm left with Ry. Ry, perpendicular distance from O is Ix. So solving for Ix, what do we get? Yun. Tama na, it's 6.90. So correct, DeAndre and Gian and Adrian. So Ibayon and Rivera. Ibayon. Rivera. R. Yeah. Okay, so 6.90 meters. That is a complete answer to this number. Number 2. Okay. Any questions for number 2? Please answer in the chat. Okay, great. Let's move on to number 3. We got another truss. Uh, yeah. The Howie truss, or roof truss shown in the figure, carries the given loads. The wind loads are perpendicular to the inclined members. Determine the magnitude of the resultant, its inclination to the horizontal, and where it intersects AB. So essentially, we'll just repeat what we did earlier. There's magnitude, inclination, position. So let's start with magnitude. And what we've done is we've started with Rx. So before we do that, let's look at our drawing. These are wind loads. Okay. So for the C majors out there, you're gonna encounter this more often later on in your college life. But for now, these are wind loads. So they are perpendicular to your truss. Okay. So remember, to get horizontal and vertical components, I either need angle or slope. I'm not given angle here, I'm given dimensions. Okay. So from the given dimensions, I can figure out the angle of my truss. Okay. So this is 3, this is 3, this is 3. Considering this large right triangle. Okay. So this is 3, 3, 6. This is 2. So this slope equal to this slope. Okay. So I'm going to just include it in one part. So this is 6, this is 3. Simplifying that, it's 1 is to 2. Okay. 3 is to 6 is also equivalent to 1 is to 2. So 1 is to 2. So therefore, getting the slope of that, that's just 1 squared plus 2 squared, and that is square root of 5. Okay, gets? Yeah, I just got the slope of this. Now, this line is perpendicular to this line, so let's use perpendicular angles now. I'm gonna use it here since all of these 3 have the same slope. So I'm just gonna do it in one. So this line, perpendicular to this line. I'm gonna draw another line. This line, okay, perpendicular to this line. Therefore, angle between them is the same. Therefore, the slope is also the same. Or if you don't want to go through that, you can just write, if two angles, or if this is perpendicular to the slope, this would just be the opposite. So here, height is 1, here the base would be 1, here the base is 2, here the height is 2. And it has the same slope, or same hypotenuse, square root of 5. Okay. Again, if a force is perpendicular to a slope, so ito, you have your force perpendicular to this, angle is the same, or slope is the same, baliktad lang. So again, 1 here is vertical, here it's horizontal, 2 is horizontal here, here it's vertical. Okay? Yan lang. So remember that, para hindi na kayo mahirapan maglipat ng slope. Okay, so now I have the slopes of my forces. Let's start with this one. So this is to the right, therefore positive 1, 1, 2, 0 multiplied by horizontal component 1 over square root of 5. Do the same thing here to the right, therefore positive 2, 2, 4, 0. Again, times 1 over square root of 5. And then lastly, our next one, 1, 2, 0 times horizontal component 1 over square root of 5. And then these 3 don't have horizontal component, and then this is to the right, so plus 2,000. Please solve. What's the answer? Correct, 4003.52. So who's that? Skylar and Aliana. So pamat-mat Domingo. So 4003.52. Store that in your calculator. Do the same thing for RY. So 1120 downward, therefore negative. Vertical component is 2. So 2 over hypotenuse square root of 5. Do the same thing here. So this is again downward, therefore negative 2240 times 2 over square root of 5 minus 1120 times 2 over square root of 5. And then all of these are downward. So minus 3,000, minus 2,000, minus 1,000. This doesn't have a vertical component. So please solve. What's the answer? Correct, Skylar and Jasmine. Yes. All of you have 2 points now. Okay, correct, Luis, Navarro, and then Samantha. And wait, may naun, hindi pala. Sobra na. So 10,000 yun. So once again, correct Skylar, Jasmine, Luis, and Samantha. So Navarro and Navarro. Oh, Navarro. Okay. So 10,007. Negative 10,007.03. Once again, store. Solve for R. What's the answer? Yeah, it's 10,778.17. Correct. Maria and Vivian. A joke lang. Yeah, tama. Vivian and Maria. So, Maho and Reyes. Reyes. Sabi sa inyo magkaka-chance din kayo. So, once again, that is 10,778.17. 10,778.17. That is the magnitude, and our unit is newtons. Great. And then theta, arctangent, ry over rx. What's the answer? Need for speed. At least, hindi nakakaantok masyado. So, sino na una? John, yes, correct. Skylar, correct. 68. Okay, John Carlo, correct. And then once again, Maria, correct. So, Kinia and Reyes. Yan. O yan, kota ka na, Maria. Kasunod. State point 2. And then direction, positive, negative, therefore downward to the right. Okay, and then lastly, what's the question? Where it intersects AB. What's AB? This is AB. So where it intersects. So now you're gonna guess the position. Let's say So my force is to the right downward. So it's gonna be this way, right? I'm gonna guess this is where my resultant is. Okay, now what we're looking for is its intersection. So you're gonna take a reference point. Let's say A. I want to take it from A. Okay. So this is the point of intersection. So let's call that X. Okay. This is the point of intersection. Resolve your resultant into Rx and Ry or rewrite. So this is Rx. This is Ry. Then to get the position, like usual, we're gonna use the concept of moment. So concept of moment, we're taking it about point A, or that's our reference point, and equals RD. In this case, Rx passes through A, so ignoring that, so I'm left with Ry times distance X. Okay. So earlier I solved for moment. I solved for moment first, just so you can have an idea of the orientation of your resultant. Here, I didn't do that anymore. I just equated it immediately to Ry times X, because you can safely say that my resultant will be in the middle of these cluster of forces. Okay, it won't be here. Most likely it's here. Okay, so now let's solve. Summation of moment at A. Let's start with here, passes through A. So ignoring that, next, 2240. We're solving that into components. Okay, so let's start with Rx, Fx. Rotating it about this, it's positive. So positive 2240, horizontal component. So that is times 1 over square root of 5. Perpendicular distance is this. And what is that? So take note, our slope is 1 is to 2. 1 high, twice base. If my base is 3, therefore the height should be half of that, because again, it follows the slope. Therefore, height should be 1.5. Okay? Once again, bakit? Slope of this is 1 is to 2. Therefore, slope of this should also be 1 is to 2. This is 3. Half of that is 1.5. Ganun lang. Or you can use ratio and proportion for law of similar triangles. You have your smaller triangle, your larger triangle, and your even larger triangle. Okay? You can do that as well. Up to you, whatever is more convenient for you. Okay, so therefore, perpendicular distance is this, which is equal to 1.5. Next, y component. Rotating it about A, again, that's positive since clockwise. 2240 times vertical component is 2 over square root of 5. Then perpendicular distance is this, therefore that's 3. Okay, do the same thing here. So 1120, again, let's start with the horizontal component. Rotating it about A, that is clockwise, therefore positive 1120, horizontal component, so multiplied by 1 over square root of 5. Then multiplied by perpendicular distance. This, which is equal to this, which is 3. Next vertical component, again, that's clockwise, so plus 1120 vertical component, so 2 over square root of 5. Perpendicular distance is this, so that's 3 plus 3, 6. Next, let's move on to the other forces. So let's start with 3000. So that's clockwise once again. So plus 3000, perpendicular distance 3. Next, again, that's also clockwise, 2000, perpendicular distance 6. And then here, clockwise plus 1000, perpendicular distance 3, 6, 9. And then lastly, we have this, clockwise, so plus 2000, perpendicular distance, again, extending its line of action, it's this, which is again equal to 1.5. So obviously, this is also 1.5. Equals Ry, and this is your Ry is clockwise, So positive RY, 10,007.03 times x. Okay, solve for x. It's a very long solution. Correct, it's 4.75. Yan. Okay, so sino yun? Correct, Angela. Correct, Erwin. Correct, John. Correct, Jasmine. Correct, Joanna. So yung wala pang score is John, Philip, and Joanna. So pamitan, tama no? Pamitan. Tama no? Yan. Okay. So it's 4.80 to be exact. 3,000, 1,000, 1,000. Okay. So 4.80 meters to the right. So I got a positive answer for x. So that means my assumption for the position for resultant is correct. So it is indeed 4.80 meters. And then to complete this, indicate to the right of your reference point. To the right of A. So for practice, you can solve this using or taking B as your reference point. So summation of moment about B. You should get the answer 12 minus x. So 12 minus 4.8 should be your answer if you take it about B. Okay? So that is your number 3. Any questions for number 3? Okay. Magkakaanak ako bigla sa inyo. Okay. So last question before I give you your break. Let's just finish this, okay? Determine the resultant of the three forces acting on the dam shown in the figure and locate its intersection with the base AD. For good design, this intersection should occur within the middle third of the base. Does it? So reading this again, what we're looking for is resultant and then its intersection for base AB. So resultant, again, that includes magnitude and inclination. And then we're already going to look for the position, which is the intersection at AB. So we'll just repeat what we did earlier. So I guess this is number 4. Yeah. Okay. So let's start. Again, we're usually starting Rx. Let's start with the leftmost. So 10,000 to the right, therefore positive. Next, this doesn't have a horizontal component. And then what about this? So this is another manipulation of angles. So recall alternating interior angles. So yan. If this is 60, therefore this is also 60. And then this is perpendicular to this, so this total angle is 90. 90 minus 60, therefore this is 30 degrees, okay? So this is to the left, therefore negative 6,000. Horizontal component would be cosine 30, since this is taken from the x-axis, or from the horizontal. So I can use cosine. Okay, what's the answer? Correct. Sino na una? Correct, Angela, Jan, Adrian, Kylie, Romay. So correct, Rivera and Johnson. Johnson. Okay, nice. So 4803.85. Store that. Do the same thing for RY. So it doesn't have a vertical component. This is downwards, so negative 24,000. This is downwards, so minus 6,000 sine 30 for the vertical component. Okay, what's the answer? Correct, it's 27,000 for negative 27,000. Who got it first? So correct, Skylar, John, and Philip, and Jermaine, and Kathleen, and Ivy, okay. And Batu. Okay, so yung wala pang 2 points, I believe would be Kamitan. Yep. So correct, Philip, and then Johnson. Yeah. Oh, Batu. Wait, did you answer? Not yet. Okay. So Pamitan and Johnson. Okay. Okay, so 27,000 negative. And then our, you already know, Rx squared, Ry squared. Okay. Correct, John, Aliana, and Batum. So Domingo and Batum. 27,424.02. So against, I don't have to store that. 27,000 pounds. Okay. So that's the magnitude of your resultant. Next, we'll take the theta. So that's just arctangent Ry over Rx. What's the answer? Correct, John, Jan, Nicole, Skylar, and Carlo, and then the Leon. So Kenya and the Leon. We already did the Leon. Next, who else? Manalastas. So 79.91 degrees. Someone's mic is open, please mute. And then direction downward, since negative, then positive, therefore to the right. So downward to the right. Okay. And then last, what are we looking for? Intersection within AB. So intersection AB, again, we're gonna guess the location. It's downward to the right, so that direction is this way. So I'm gonna guess this is my R. Okay? And then you're gonna take a reference point. Now usually you should take it wherever it's easier to compute. Now look here, if I take it from A, I'm gonna have to figure out the components of the 6,000 force. However, if I take it from B, perpendicular distance of force F from B is already given to be 4 feet. So I'm gonna take moment at B so that I don't have to figure out the component of that. Okay? So summation of moment at B, and then taking the component of my resultant R here. So this is your Ry, Rx, Rx passes through your point in question B, so I'm left with Ry, and then the distance that we'll get, let me just move all of this downward. Oh, okay. Okay, so the distance that we'll have would be, let's call it x. Okay? So therefore, summation of moment B would equal to rotating Ry about this, that is counterclockwise. So negative value of Ry, okay, and then multiplied by x. 10. And then just compute. Let's start with 10,000. 10,000 about B, that's positive, since clockwise. Perpendicular distance, 6. Next, 24, rotated about B, that's counterclockwise, so negative 24,000. Multiplied by distance. This total length is 18. This distance is 7. Therefore, this distance will be 18 minus 7, that's 11. Okay, so 11. And then lastly, 6,000 rotated about B. That's once again counterclockwise. So negative 6,000 times perpendicular distance given to be 4. And then equals negative Ry. Ry is 27,000. Solving for x, what do we get? Correct, Skylar? Correct, Angela? Correct, Jermaine? Correct, Janet? Jasmine? Okay, correct, Samantha and Jade? Okay, Simone? Yeah, so correct, Jade, and then Samantha. So it's 8.44. And then to be more specific, feet to the left of your reference point. My answer is positive, therefore correct assumption of position. So it is indeed to the left of B. And then we have another part of that, or asked, for good design, it should occur within the middle third. So the question is, does it? So drawing that, this is 18 inches, or 18 feet. So dividing that into 3, that is 6, 6, and 6, right? 12, 18. Distance is 8.44 to the left. So this is where my R would be, right? So that's your X. So therefore, just by inspection, yes. Yes, it's within the middle third. Okay? So there. That is the complete answer to the final question for resultant. Any questions? Okay, great. So that ends the topic for resultant. Okay, so we're gonna have a break. Ilang minutes gusto nyo? 15, 20, 25, 30. Ilang minutes kailangan nyo? It's fine. I don't mind. Ilang kailangan nyo? Marami na tayong sinolve eh. This is 10? You solved 10 problems? Yeah. Good job, guys. Yeah, we solved around 10. No, 11. We solved 11. I don't know, 10. Kailangan ko lang kayo magla-lunch. Sige, fine. 30-minute break. So, kailan tayo babalik? 15, 41, let's say it's 1:45. I'll see you at 2:15. Yeah, big brain tayo. Yeah, yeah. So, I'll see you at 2:15. You may take your break. Okay, I'll start the class immediately at 2:15, okay? Then, I'll just keep this open. Just come back at 2:15. Yeah, eat well, yung mga gustong mag-nap, mag-nap na para ma-recharge kayo sa next topic. Yeah, sunod-sunod to sa recording. So, full 3 hours ang i-upload sa YouTube. Okay, welcome back. It's 217. So once again, we're done with the resultant of force systems. Now, moving on to the next topic, it's equilibrium. So for now, we're discussing parallel force and concurrent force systems. So let's talk about equilibrium. So it's equilibrium is a condition where the resultant of a system of forces is zero. So if you can imagine, remember resultant is the effect or total effect of a force on a body. If your resultant is zero, therefore your system of forces should not have any effect on your body. So that means two things. Either your object is at rest or remains at rest, or your object remains in constant motion. So when a body is in equilibrium, it is either at rest or is moving in a straight line with constant velocity. So straight line here is important because even though, for example, you're moving in a circular path and you're maintaining your speed, since it's a circular path, the direction changes. So there's still a change in velocity. So in essence, your object is not in equilibrium. Okay? So it should only be at rest or moving in a straight line with constant velocity or constant speed in this case. Okay? So that's your equilibrium. So in short, the equations for equilibrium now are just the same for the resultant, but we're going to equate it to zero. So let's start with concurrent force systems. Two forces are in equilibrium if they are equal and oppositely directed. Okay, that's an example of a collinear system, however, oppositely directed. So as you can imagine, same magnitude, opposite direction. So one is positive, one is negative. Taking the summation of that, you'll get zero. So that's in equilibrium. Next, three coplanar forces in equilibrium are concurrent. Okay. So that's just a property. If you have three forces and if you solve for the resultant and it's zero, meaning they're in equilibrium, therefore those three forces are in equilibrium. And then, those three forces are concurrent. And then lastly, three or more concurrent forces in equilibrium form a closed polygon when connected in head to tail manner. So you might have discussed this in your previous physics classes, where you can take the summation of forces using polygon method or triangular method using sine law and cosine law. Okay, but we're not going to do that. Instead, I want to practice with you the analytical approach for solving for equilibrium. Okay, you can try and practice it at home using the polygon method, but again, we'll use method of analysis. Okay, so as mentioned earlier, equations are the same, concept is the same, the only difference is everything now is equal to zero. So we'll start with concurrent force systems. For concurrent force systems, if you remember, we're not dealing with moment yet because all of our forces meet at a common point. Therefore, they don't apply moment, okay, since there's no distance from a reference point. So therefore, all our equations are just summation of force x equals zero and summation of force y equals zero. So let's have a few examples. There. The system of knotted cords shown in the figure support the indicated weights. Compute the tensile force in each cord. The tensile force. Let me just get this figure. I wasn't able to copy it. Okay. All right, so this is number one. So here, in our topic of equilibrium, we're going to practice drawing our free body diagrams. So previously in our resultant, we didn't do that much, but here now, we will. So the first step is draw the free body diagram of your illustration. So usually with concurrent force system, you start with a point and then just draw your forces. All of these are cords. So what I like to do is draw all of your cords or all of your wires, cords, string, rods away from your point. So all of them I assume to be in tension. So that means this is your force A. Let me use a blue color. So that is your force A. Next, weight is always downward. So weight downward, 300 pounds. Okay, we're going to do this one at a time. I'm starting here. And then next we have this. And then this is your x-axis. So this force, let's call it B. Again, away from your point. And then when I indicate the angle, I always like to put it with respect to the x-axis so that my equation force horizontal is equal to force times cos sine theta is applicable. Okay. And then lastly, this is C. Okay, so I want to get this angle and this angle. So look here, this is 30, right? So this would be 30. Again, I want to take the angle from the x-axis or from the horizontal. So 90 minus 30, therefore, this would be 60 degrees. Okay? Do the same thing for B. If this is 60, and as you can see, angle between B and C is 105. To get this angle, it's just 105 minus 60. Okay? Which is 45. So 105 minus 60, 45. Do the same thing for the other system. So here. So take note, I have a string that connects the two systems. Okay? So that means the magnitude of force for these two systems should be the same in this string, but the direction should be opposite. Okay? So for example, here my direction is downwards to the right. For my next drawing, it should be upwards to the left. Or if you don't want to remember it that way, just remember my assumption here is force C is away from my point. So I should copy that at this system as well. So it's also away from the point. Okay? So this is my C. Okay? The whole thing. And then this I have B here. And then I have weight always downward, 400 pounds. And then again, figure out your angles. So this is the angle for C, this drawing. Okay. So again, this is 30. Obviously, this is 90. So 90 minus 30, this is 60. Or you can just remember whatever angle you have here should also be the same here since they're the same force. Okay. And then force D. Okay. This is 75. Okay. So therefore, this is 75. I want to get this. This is a 75. 90 minus 75, that's 15. So this is 15 degrees. Okay. So now I have two free body diagrams. You're going to start with your fx equals 0 and fy equals 0. Okay. So usually you're going to start with the system with the least unknowns. Or free body diagram. We call free body diagram FBD as well. So start with FBD with least unknown. And what would that be? The left drawing, the right drawing? Answer in the chat. Left or right? Where should we start? Tulog pa utak niyo?
Left.
Ulit ha. Least unknown. Konti unknown. So correct, Carla and Ivy, it's right. Okay, so let's count. Unknown for the left side, it's A, B, and C. That's 3 unknowns. Unknown for the right side is just C and D, 2 unknowns. So we're going to start with the one with the 2 unknowns. Okay? Because that just makes things easier. You can technically start with the left, up to you. But again, this just makes things easier. So starting with the right side, okay? So you can start with force F, force horizontal or force vertical. You can start with horizontal. Okay, so now it's all equal to 0 if it's in equilibrium. Okay. So in the you know if an object is in equilibrium if it's not moving. This system should not be moving. So again, this is in equilibrium. So Fx equals 0. Okay, let's start. C. C is to the left, so negative C. X component would be cosine 60. Okay. Next, B to the right, therefore positive B. And then cosine 15. This doesn't have a horizontal component, so therefore 0. Now, as you can see, I can't solve anything for that. But what you can do is just denote that as your equation number 1. Okay? Now you're going to do the same thing for summation of forces y equals 0. Again, starting with C upward, therefore positive C sine 60. D is upward, therefore positive D sine 15. 400 is downward minus 400 equals 0. Again, I can't really solve anything from this, but I can denote that as equation number 2. Now, as you can see, 2 equations, 2 unknowns. You can solve this using your calculator or manually. Up to you, whichever you're more used to. I suggest using your calculator so that you don't have a long solution. So please solve what's C and D. Or what's C? What's C first? Okay. Again, aralin nyo na or study your calculator options, how to use equations. For me, it's mode 5, mode equation. And then option 1, you want to get, since this is 2 unknowns, you want to choose the ax plus by equals cn, I believe. And then you're going to get a matrix. A would be negative cosine 60. B would be cosine 15, then 0. Then the next row would be sine 60, sine 15, then 400. Positive 400 since you should write your equation in this form. Okay? And then the first answer that it will give will be for C since that's the first column and first row you input. And the next answer you get will be your D. Once again, I urge you to study that so that your solution is short. So, no, incorrect. Make sure your sign is correct. Okay. Or again, you can solve it manually kung ayaw nyo mag-calculator. No, nope, nope. Yun, correct. Correct, Angela, Garen. I'm gonna include this as a new lecture day, okay? So, new column, Garen, A, B, C, D. So, correct. C is 400 pounds. And then D is 207.06. Actually, it should be positive, okay? Why are you getting negative? Yeah, it should be positive, your answer. Because a negative means your assumption for direction is incorrect. Okay? But I'll try on my own if I get a negative or a positive. Yeah, it's all positive. make sure in the last row and column it's positive 400, okay? Because you're gonna transpose this to the right since our equation is in the form of ax plus by equals cn. So this should be c sine 60 plus d sine 15 equals 400. Okay. So these are your answers for C and D. Okay. Once again, try to practice that at home. Next, after you've solved for one free body diagram, we're gonna move on to the next. So using this, let me mark out my free body diagram. Let's call this one. We call this 2. This is for 2. And then solving for 1. Okay. So looking here, I already know C. C is 400. Okay, so usually you want to start with the equation that's gonna solve something. So if I try summation of forces vertical equals 0, I don't have to include A. There's no vertical component. So I'm left with unknown B. And C is known already. It's 400. Okay. So the only thing unknown is B. But if I do summation of forces X, the unknown will be A and B. Okay, so that's why I'm going to start with summation of forces Y equals 0. Again, you can start with summation of forces X. That doesn't matter. You can just move on to Fy next when you don't have anything to solve for X, and then go back to summation of forces X to complete your solution. Okay, but again, to shorten your solution, I'm going to choose summation of forces Y first. Okay, so let's start with B. B is upward, therefore positive. B, again, vertical component, sine 45. Next, C is downward, therefore negative C. C is 400. And then sine 60. 300 is downward, so minus 300 equals 0. Please solve for B. What's the answer? Correct, it's 914.16. Kathleen and Jasmine. So, first. Huwag kayo mag-copy-paste. Oh, anak ko. Okay, so Dupra and Alanis. Okay, wait lang. Okay, B, 914.16. Okay, so that's already the answer for B. And by the way, all of my answers have been positive so far. So therefore, all my assumption for the direction of my forces is correct. Now, usually string is always tension. And tension means away from your object. Yeah. And then now I can solve for y. X equals 0. Let's start with A. A is to the left, therefore negative A. B is to the right, therefore positive B. Cosine 45. C is to the right, so plus C. Cosine 60. No horizontal equals 0. I know B. I know C. I can solve for A. Scratch. This is full. Y. No. Yeah. Alright. So wait lang. I'm encountering a problem. Puno ulit scratch disk ko. Give me a second. Right back, issue resolved. Okay, once again, C cosine, where was I? 60. And I solved for A. Yes, who got it first? 846.41. Who was that? Oh, I think I already gave this pointer. Ano? Okay, so Dupra and Kayabyab. I don't know. Garding and Dupra. Okay. Kota ka na ulit, Dupra. Ikaw din, Garding. So once again, it's 846.41 pounds. Okay, so that's one way to solve for this. Just solving as is. However, there are times where you have to rotate your axis so that to make your solution easier. So that is method 1. Let me show you method 2. Okay. So method 2, you're still gonna start with the least unknown, which is this. But now, I'm gonna rotate it in a way that one of the unknowns coincides with our x or y axis. Okay? So how do we do that? Okay. So once again, the purpose of rotating your axis is, if you've noticed in our first solution, right, I had two equations, two unknowns. So we're rotating axis to eliminate that, so that we have an equation similar to your free body diagram 1, where I'm able to solve immediately for an unknown. Okay? So again, I'm going to rotate it. Either coincide your unknown with x or y axis. So let's say I want my C to coincide with either x or y. Okay? So I'm going to rotate this. Good thing I'm using Photoshop. It's easy to rotate. I'm going to rotate it so that it coincides with the x-axis. So now, this is the x-axis, okay? So now this is my new free body diagram. You can rotate so that D coincides with an axis, okay? Up to you. Again, you can use that for practice. You should get the same answer if you do. Okay, so rewriting my given. Once again, this is C, D, and this was 400 pounds. And now, remember, I want to get the angle from the x-axis. So I want to get this and this. So everything was rotated 60 degrees, right? Okay, how do I know? For C to coincide with this, or for the negative x-axis, I need to rotate everything counterclockwise by 60 degrees. Okay, so this will move by 60 degrees, this will move by 60 degrees. Okay, so therefore, the total angle of this now would be 60 plus 15. Okay, 60 plus 15, that's 75 degrees. Okay, now same thing here. Okay, so from the horizontal, right, it moves 60 degrees counterclockwise. So this again is 60. Okay, so therefore this is 60, this is 90 degrees, this should be 30. Yeah, so now I have my new free body diagram. I can solve. So let's start. Since C coincides with x-axis, I'm going to start with summation of forces y equals 0, so that only my D is unknown. C will not be included in forces y. So let's start. D, upward, therefore positive, sine 75, minus 400 since downward, sine 30, equals 0. Solve for D, what's the answer? Correct, Jermaine and Jan, Vincent. So that is Borben Portades. So 207.06. Okay. And now I can use summation of forces X equals 0. So negative C since to the left, positive D since to the right, then X component is cosine 75, and then positive 400 cosine 30 equals 0. So please solve for C. What's the answer? Use the stored value of your D, okay? So correct Mark, Kayabyab, and DeAndre. So Kayabyab, okay. So it's 400. Okay. And then next, looking here, one of my unknowns is already at one of my axes here, A. A is already at the x-axis. So I don't need to rotate. As you can see, I can directly solve. Or if you want, after solving for B, you can rotate A so that B coincides with, B coincides with an axis so that only A is unknown when you take your summation equals 0. And then you're going to solve for A. So there are multiple ways to solve for this depending on how you draw your free body diagram. So since I don't want to rotate this anymore, I can just copy my solution. It's the same thing. As you can see, let me just combine. Answer is the same, 400, 207, and this is still 400, 207. Okay? So we call this method method of rotating axis. So you can do that to make your solution easier. Okay? Do you have any questions for number 1 for equilibrium? Okay, none so far. We can move on to the next question. Here. Okay. Next, number 2. A cylinder weighing 400 pounds is held against a smooth incline by means of the weightless rod AB. In the figure, determine the forces P and N exerted on the cylinder by the rod and the incline. So we're looking for P and N exerted by the rod and incline. Again, copy. Okay, paste. So, okay. So number 2. So once again, create your free body diagram. Now take note, this has a weight, cylinder. So my object in question is cylinder, right? Since force P and N exerted on the cylinder. So the one experiencing your force is cylinder, so that's my point. Okay. You have a weight of your cylinder, and remember weight is always downward. So draw that downward, 400 pounds. Next, you have a rod and this incline. So in this case, usually your rod will push towards your cylinder, right? Therefore, the force on your rod would be towards your cylinder. So you can draw it this way, okay? Or you can draw it this way. It's the same, like law of transmissibility, and that's your force P. Next here, I'm gonna draw that. That's your force P, okay? Next, N. So whenever two objects are in contact, or if there's a surface, there's always what we call a normal force acting perpendicular to the surface. Okay, so there's a normal force here, and perpendicular to your surface. So that's your N. Drawing it along your FBD, it could be this way. Again, you can draw it that way. Or, I mostly always like to draw my free body diagram away from my point. Okay, and now that's your N. And then angle. Figure out your angle. This is your P. Okay, this is your P, right? And as you can see, angle with the horizontal is 25. So this is now 25. And then next, N. Angle for N. This is what I'm looking for. Right? Now if I extend this, what we have. This is 55 as well for law of alternating interior angles. And then, yeah, you can use law of your perpendicular angles. Angle between them should be the same. Again, for perpendicular angles, let's figure out this line perpendicular to this line. And then, what else? Yeah. This line perpendicular to this line. So angle between them should be the same. Again, let's try that one more time. This line perpendicular to this line. Okay. And then this line perpendicular to this line. So angle between them should be the same. This is 55, therefore this should also be 55. So drawing that, okay, so this is 55, you got yourself a right triangle. Therefore, I can figure out what this angle is. So 180 minus 90 minus 55, you get 35. So this is now angle 35. Okay, and then to solve, we're just gonna use summation of forces x and forces y. Let's start with forces x. Let's start with n. So n is to the left, so negative n cosine 35. Next, p to the right, therefore positive p cosine 25. That's vertical, so ignoring that, then equals 0. Once again, I solved nothing from that. You can just call that equation 1. Do the same thing for forces y equals 0. Okay. So n upwards, therefore positive, and sine 35. Next, p upward, therefore positive p sine 35. And then 400 downward, so minus 400 equals 0. Once again, I can call this equation number 2. And if you've noticed, I get two equations, two unknowns, n and p. I can solve for this. So what's n? What's the value of n? Hmm? Sine 25. Oh yeah, sorry. Sine 25. Oh, bakit iba kayo ng sagot? 331.07. Hmm? Okay, correct, Garen. and Torres and Bajo. Garing, Torres, Bajo. Okay. Garing, Torres, Bajo. Okay, so N is 418.60 newtons. P is 378.34. Bakit iba na kuha mo? Let me check. Mali ba ako nasulat? Yeah, hindi naman. This is 418.61 378.35. Okay. Yan. So these are your answers. Yan. So ganun lang. So I'm gonna end the topic there. Just take note, strings, ropes are all in tension, wires in tension. And then if you have two surfaces in contact, that's in. You have a normal force directed perpendicular to your object. Okay, that's why N is here. And then P, although this is a rod, this rod is pushing towards your cylinder so that it doesn't move downward. That's why my force for P is this way. And so this is practicing how to create your free body diagram. Okay? Do you have any questions? Okay, great. Next meeting, Tuesday, we're gonna have your modular quiz. So topic is everything I've discussed so far, including the ones for your quiz number 1. Okay? Once again, modular exam, Tuesday, everything I've discussed so far. And then those who haven't answered your exam yet, please send me an excuse letter signed by your guardian or parents with photo of your parents' ID. Okay? And then we can schedule your exam, or you can take it on your own. Exam is open until next week, 1 week after the due date of your exam. Okay, so you can answer it immediately. Just make sure you send me your excuse letter. No excuse letter, 0 for your exam. And make sure all of you guys check if you've uploaded your solution to your seat work and your quiz. Okay, no solution is 0 as well. So please check if you've uploaded your solution. What else? We have a Facebook group. I've uploaded it. I sent the link in your Blackboard announcement, so please join that. I've uploaded a fact sheet. Also, for those who don't know, I've uploaded a course orientation file under lectures. So please read that. Also, watch the video about that so that if you have any more questions or clarifications, it might be answered there. Okay? So next week is the last week for your module 1. Remember to answer your week 1 and week 2 Coursera, and then upload the screenshot of your score with your name in the appropriate tabs in your Blackboard. Okay? Yun. Then after your modular quiz on Tuesday, we're gonna have an activity on Thursday. Group activity. So I'm gonna group you next time. And then you'll have your lecture as well. Okay? So yun lang. Since you don't have any more questions, you may go. Good luck on your exam next week. Goodbye, class.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you po, ma'am.